In this lecture, we're going to go over logic and conditionals in Excel. So what are our learning objectives? We want to create simple and nested statements in Excel to produce conditional results. We want to generate complex logic and develop conditionals. We want to predict the outcome of a conditional statement. So what are some logic basics? Logic transformation is a list of arguments into outcomes based on a decision. For example, if the traffic light is red, stop. If the traffic light is yellow, slow down. If the traffic light is green, go on. In this case, the argument are the three traffic bulbs, the decision, which bulb is lit, and the outcomes are stop, slow, or go. So how does logic in computers work? Well, computers use Boolean logic where each argument is a binary result and our overall outcome exhibits binary behavior. Binary behavior is any sort of behavior that results in two possible outcomes. So Boolean calculations are referred to as true and false, yes and no, or 1 and 0. So all of the logic that we're going to go over is either true or false, yes or no, did something occur or did it not. To do that, we use rational operators. They're usually placed between two cells in order to determine the relationship between them. The cell operator cell expressions are rational expressions, so we have greater than, less than, greater than or equal to, less than or equal to, or not equal to. So this is how you say not equal to in Excel. When we get to MATLAB, saying not equal to is different. So the first thing we're going to look at is a single conditional statement. So a single conditional statement in Excel is an if statement. So it's if something, something, something. So there's three parts to an if statement. The first part is the conditional to be met. The second part is what happens if the condition is satisfied. And the third part is what happens if the condition is not satisfied. So an if statement is always the logical test, value of true, value of false. Any text in if statements must be placed in quotes. So if I want to display the word higher, I have to put higher in quotation marks. Two quotation marks next to each other will produce a blank cell. So for example, if I use the statement, if B5 is greater than 10, higher, comma, two quotation marks. If B5 is greater than 10, it will display the word higher. If not, it will create a blank cell. So let's look at an example. We want to take the square root of the sum of two variables. The variables are located in F10 and G12. If the sum of A and B is negative, we want to display an error message. Otherwise, we want to calculate the square root of the sum. So how are we going to start? Well, first we're going to start by writing our if for our function. And then we're going to put in our logic test. Our logic test is if F10 plus G12 is less than 0. If it is less than 0, we want to display an error message. Simply I'm going to write the word error. Note that it's in quotation marks. If that is not true, I want to calculate the square root of F10 plus G12. You could phrase this logic the other way and say if F10 plus G12 is greater than 0, calculate the square root, and if not, produce an error. However, the problem stated it in such a way that it's looking for the negative version of the logic. So it wants to see, we're testing if it's negative first. Let's look at another example where we want to indicate whether or not each material has a thermal expansion value greater than the maximum value set by the user, which is in cell J13. We're trying to figure out what should be typed into cell J4 that can be copied down to cell J11 to accomplish this. And our logic is if beta is less than the maximum value, the cell should display the thermal expansion value from column E. If it's greater than or equal to the maximum value, they should display the word high. So how are we going to implement this? Well, there's two different ways of it. Again, it depends on how you look at your logic. First way is if we say if our value is less than the maximum, which is always in cell J13. If it is less, display the value in the corresponding row, in this case in E4 if I'm typing into E4. If not, display the word high. Again, you can replace that logic by saying if E4 is greater than or equal to the maximum, display the word high, and if not, put in the value in the corresponding row. So lots of times there are two different ways to phrase your logic statement depending on how you look at what is true and what is false. These do the same thing, it's just how the test is occurring. So we're going to move on to nested conditional statements. If you have more than two outcomes that exist, you're going to need nested if statements. So how they work is you have your first logical test and the first value if it's true. Then you can have it, where you would have the value if it's false, you can write an entire another if statement with the second logical test, the second value if test 2 is true, and then the value if both are false. Each statement only contains the same 3 parts, and you have to make sure you have your parentheses in the correct places. So let's look at a way to do this. We want to figure out the phase of our water. If it's less than 0, we want solid. If it's between 0 and 100, we want liquid. And if it's greater than 100, we want gas. So we're going to write an if statement to determine this, given the input in cell Z22. And since we have 3 outcomes, we're going to need nested if statements. So let's unpack this answer. So I wrote if Z22 is less than 0. So if this is true, write the word solid. If it is false, I need to put in another test because I still have to figure out if it's liquid or gas. So that is why this entire statement here is what happens if it's false. So if the first test is false, I want to see if my second test is true, which asks if Z22 is greater than 100. If Z22 is greater than 100, display the word gas. If not, that means both of my logic tests have failed, and I want to say it is liquid. There is in Excel a simplified nested if statement. It's called if-s, and an if-s statement has at least 2 parts. It's the condition that must be met, and what happens if the condition is satisfied. The remaining pairs, so 3, 4, 5, 6, and so on, are more conditions and more values. The additional condition value pairs can be included, so you can keep going. It's useful for any if else if type logic where you have those multiple outcomes that can occur. So in this text, and again, just like in an if statement, any text has to be in quotes. So if we look at an example here, we want if a number is greater than 10, we want to write the word higher. And if a number is less than or equal to 10, we want to write the word lower. So here is our first logic, our first response, our second logic, our second response. So it's going to go down in order. So you have to be careful with the order that you put them in. This just replaces writing out a full second if statement, and it can be useful for a lot of our if-else logic types. So if we look back at that same example that we did with the 3 phases of liquid, if we write an if-s statement, what we're going to have is if-s, so I'm asking if Z22 is less than 0, write solid. If Z22 is greater than 100, write gas. And then I'm going to say if 1 equals 1, liquid. This is the way to get the last output to display, because this is a logic statement that is always true, but the problem is it has to get through this one and then this one to get to this one, so at that point it is always true. So that's how we get the third option to occur. You could also put in an additional logic statement that would pass after these. For example, if it's greater than 0, but if it's greater than or equal to 0 but less than or equal to 100. So let's look at another example. We're back at that example that we were looking at where we were trying to write the high values for thermal expansion, and this time we want to look at the specific heat, and we want to determine whether or not each material has a specific heat at least as high as the value given in K13, as well as a thermal conductivity no greater than the value given in K15. So we're trying to figure out if our values are between the minimum and maximum CP and K. So we're trying to figure out what we should type into cell K4 that we can then copy down. So remember, we're going to use our cell addressing. And the logic we're trying to work out here is if CP is too low, we want it to contain CP low, regardless of the value of K. If the CP is acceptable but K is too high, the cell should contain K high. And if both CP and K are met, we want to leave the cell blank. So first we're going to look at this if we're going to use nested if statements. So the first criteria we're trying to check is if the CP is low. So if the CP is low, so here we have our logic of here's my value of CP. If it is greater than or equal to the minimum, and this would be true, and I would go on to the second if statement. If this is false, I would go all the way down here and produce my answer of CP low. So if this is true, it's going to trigger our second if statement, which then asks, is my thermal conductivity less than the maximum? If that is true, it's going to put in a blank space, which is our criteria if everything is acceptable. And if that is false, it's going to put in K high. You could reverse the logic and put things in a different order. So if we look at another example where we have the following typed into cell L4 and copied down to L11, we have the at. So I want to calculate. I say if the average of C4 to C11 is greater than C4, go ahead and trigger the second if statement that says if C4 is less than C13, put in the value in F4. If not, put in a blank, and if everything is wrong to begin with, put in a blank. So what will appear in cell L4, so we're right over here if this happens. We're working with values of C, so we're looking at our density. So the average density comes out to be 7,927.5. So my average is not greater than my value in C4. So it is going to fail the first logic and put in a blank. If I then drag this over to, if I then modify this, because I was in cell L4, I'm now going to cell L9, so I'm now going down here to L9. I'm trying to see if the value of my average is greater than cell 9. So in cell C9, I have 7,780, which is not greater than, sorry, the average is greater than the value in C9, so this first logic statement is passed. So we're going to move on to our second logic statement, which is asking if the value in C9, which again is 7,780, is less than the value in C13, where C13 is our maximum. That is true. So it's going to display the value of an F9, which is 460. Okay, so you have to work through the logic statements piece by piece to figure out what's true and what is false. As if that was not complicated enough, we're going to add to it by having logical operators. Logical operators can be used in our if statements for when multiple criteria need to be looked at. For example, if you use and, it returns true if and only if everything in that statement is true. It returns false if one is false. Or returns true only if one statement is true, and returns false if both are false, and not inverts your logic. So let's look at this example here. We're trying to figure out what will be typed into M and copied down to M11. I say if, so I'm asking my logic here, and the first thing I'm asking in my conditional is and, so I'm saying both of these have to be true. So if J4 is equal to high and K4 is not blank, say both are bad. So this is the logic that I'm asking. This is what happens if it's true. If it is false, we're going to trigger the second logic that says if or. So if this is true or this is true, write one bad. If that fails, we can say that everything is okay. So I wrote this in, so we're in M5. So let's look at 5. The first thing we're going to ask is J4 high and K4 blank? Well, no. J4 is high, but K4 is not blank. So both are not bad. We're going to trigger our second logic. Is J4 equal to high or K4 blank? So yes, one of those is true, so it's going to display, it should display one bad. Oh, sorry, I was looking at M4, the problem is asking about M5, so let's look at that. So in M5, we'd be asking if J5 is equal to high and K4 is blank. Well, both of these are not true. Sorry, K5 is blank, but J4 is not equal to high, so it's both are not bad. So then we're triggering our second statement. So K4 is not equal to high, which is okay, and K4 is not blank is what I'm asking. K4 is blank, so that fails, and we get to the value of okay. Remember, this means not. So K4 not blank. So let's look at M11. So down here in M11 we have J11 is equal to high and K11 is blank. So we failed the first logic because even though J11 it says high, K11 is blank, so it fails the logic test that it's not. So they're not both bad. So then we get to our OR statement. Well, J4 is equal to high, so it doesn't matter what's in K4. We're going to get the value of 1 bad. So now we're trying to figure out which cells will show both bad. So we need to figure out which cells in column J say high and aren't blank in column K. So that's going to be M4 and M7. So that's our rundown of logic in Excel. Remember, an if statement has 3 parts. You can nest them. I think you can nest them up to like 60 something. You can also use an if-else statement for repeated if-else logic. And then to make your if statements more complicated to determine logic, you can use your and or and not statements. For example, and both criteria has to be true for the whole statement to be true, or only one does, and not invert your logic. Should review the logic forms in Excel. For example, equals means equal, less than, greater than, less than or equal to, greater than or equal to, and the odd one here is the less than greater than sign, which means not. Next week we're going to look at logic in MATLAB, which follows the similar pattern but has a different syntax.